Welcome to my channel. Today we will talk about Neptune. When looking up at a clear night sky, you can spot various planets with the naked eye. However, Neptune, the eighth planet in our solar system, remains elusive. Even though it can technically be visible under ideal conditions, its distance from Earth and small apparent size make it extremely faint. Known as the smallest gas giant, Neptune is the furthest planet from the Sun. Despite being so remote, Neptune's atmosphere is surprisingly active, exhibiting powerful storms and record-breaking wind speeds that raise intriguing questions about this icy world. Historically, Neptune's discovery was unprecedented. Unlike other planets, Neptune was found through mathematical predictions rather than visual observations in 1846. French mathematician Urbain Le Verrier noted unexplained shifts in Uranus' orbit, which led him to hypothesize that another planet was exerting a gravitational influence using his calculations. German astronomer Johann Galle found Neptune within 1 degree of Le Verrier's predicted position. This successful discovery marked a milestone in astronomical methods. Shortly after Neptune's discovery, its largest moon, Triton, was identified. However, given Neptune's considerable distance from Earth, the limitations of ground-based telescopes made further study difficult. It wasn't until the 1989 Voyager 2 mission that significant details about Neptune were revealed, including its faint rings and several previously unknown moons. As the most distant recognized planet from the Sun, Neptune orbits at an average distance of about 30 astronomical units, AU, or roughly 45 billion kilometers. This vast distance makes travel to Neptune challenging, with current technology requiring approximately 13 years for a probe to reach it. Neptune's extreme distance results in an orbital period of 165 Earth years since its discovery. Neptune has yet to complete even one full orbit around the Sun. From our perspective, unsurprisingly, Neptune's distance from the Sun contributes to its frigid environment, with atmospheric temperatures averaging around -201 degrees Celsius, among the lowest in the solar system. Neptune's axial tilt of approximately 28 degrees is similar to Earth's, resulting in seasonal variations. However, each Neptunian season lasts for around 40 Earth years. Currently, the southern hemisphere is experiencing spring, a season that brightens this part of the planet due to increased sunlight. Neptune's atmosphere is remarkably turbulent, with the fastest recorded wind speeds in the solar system at the equator. These winds can reach an astonishing 2,160 kilometers per hour, nearly supersonic. Intriguingly, many of these winds move westward, opposite to the planet's rotation, creating banded atmospheric patterns similar to those on Jupiter. The Voyager 2 mission also documented massive storms on Neptune, including the Great Dark Spot, a storm approximately the size of Earth, and the smaller Small Dark Spot. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's storms appear transient, forming and dissipating over time. When astronomers observed Neptune in 1999 using the Hubble Space Telescope, they found that the Great Dark Spot had vanished. But other storms emerged in subsequent years. These fast-changing weather patterns make Neptune an especially dynamic world. The differences in atmospheric conditions between Neptune and Uranus are notable. Both planets have similar sizes and compositions. Yet Neptune's winds are significantly stronger, with wind speeds on Uranus reaching only about 900 kilometers per hour. Such contrasts suggest that additional factors beyond solar energy influence Neptune's climate. One possible explanation lies in Neptune's internal heat. Despite its distance from the Sun, Neptune emits more heat than it receives, whereas Uranus radiates very little heat. Some scientists theorize that Uranus may have lost its primordial heat due to a massive collision billions of years ago, which would explain its cooler temperatures. Neptune, on the other hand, likely retained its internal warmth, which could account for its intense atmospheric activity. Neptune's internal structure resembles that of Uranus. The planet's atmosphere consists primarily of hydrogen and helium, with small amounts of methane responsible for its deep blue color. Beneath this atmosphere lies a liquid mantle of water, ammonia, and methane ice, surrounding a dense core. Scientists believe that the intense pressure within Neptune may break apart methane molecules, potentially creating diamonds. that precipitate through the mantle in a diamond rain. Although this theory remains unproven, laboratory experiments have replicated the extreme pressures found on Neptune, supporting the idea of diamond formation within the planet. Another intriguing aspect of Neptune is its magnetic field. Unlike most planets, Neptune's magnetic field is highly tilted relative to its rotational axis. With an angle of 47 degrees initially, scientists thought this might be due to Uranus' extreme axial tilt. But Neptune's more typical axial orientation suggests otherwise. The prevailing theory is that Neptune's magnetic field originates not from its core but from an electrically conductive layer within its mantle. Resulting in this unusual tilt, this phenomenon causes Neptune's auroras, known as SAR arcs, which are extremely faint due to the planet's distance from the Sun and the low influx of solar particles. Unlike the polar auroras seen on Earth, Neptune's SAR arcs appear around mid-latitudes and are typically invisible to the human eye. Neptune's ring system, though faint, adds to its allure. Like other gas giants, Neptune has rings. Although they are among the faintest and least dense in the solar system, there are 5 main rings, named in honor of those who contributed to the planet's discovery and study. The innermost ring, the Gal ring, is wide but faint, followed by the Le Verrier ring, which, despite being brighter, spans only about 113 kilometers. Next is the Lassell ring, a broad band that stretches approximately 4,000 kilometers, with a slightly brighter Arago ring on its outer edge. The outermost and best studied ring, the Adams ring, is notably thin at just 35 kilometers in width. This ring is particularly fascinating because it contains several bright arcs that appear as stable clusters of particles, a feature not observed in other planetary rings. These arcs could be due to gravitational interactions within the ring, but their exact cause remains unknown. Neptune's moon system further enriches our understanding of this distant planet. 14 moons have been identified, each named after a water deity from Greek mythology, Triton. Neptune's largest moon is unique as it orbits in a retrograde direction, suggesting it was likely captured rather than forming with the planet. Triton's gravitational influence could have played a role in forming Neptune's rings, possibly through collisions that created ring particles larger than Pluto. Triton has a thin atmosphere, and Voyager 2 detected faint clouds on its surface. The moon's retrograde orbit and its inclined path relative to Neptune's equator hint at its past as an independent body that Neptune eventually captured. The next largest moon, Proteus, has an irregular shape with significant crater impacts at about 400 kilometers across. Proteus is larger than Saturn's spherical moon, Mimas. The irregular shape suggests that Proteus may have experienced substantial collisions in the past, leaving large impact craters. Inner moons like Naiad and Thalassa orbit close to Neptune's rings, likely acting as shepherd moons that help maintain the ring structure. The outer moons, with irregular shapes and orbital paths, may have been captured later. Among these, Psamathe and Neso, the furthest known satellites of any planet, take approximately 25 years to complete a single orbit around Neptune. This extended orbital period is due to Neptune's large hill sphere, the region where its gravitational influence is stronger than the Sun's. Located so far from the Sun, Neptune's gravity has a larger effective range, allowing it to capture and maintain distant moons. Each of Neptune's features, from its intense storms and striking blue hue to its unique rings and distant moons, paints a picture of a world that remains both beautiful and mysterious. The distant reaches of our solar system hold surprises, and Neptune, with its complex climate, unusual magnetic field, and fascinating satellites, is a reminder of the solar system's rich diversity. As we continue to study Neptune, it challenges our understanding of planetary science and demonstrates the intricate forces at play within our cosmic neighborhood. Thanks for watching. Make sure to like our video, leave comments, and subscribe also. Click on the video showing on your screen to watch another of our interesting videos. See you there.